Now I will discuss about the modern periodic table. Modern periodic table. This is a very important periodic table. Look at that. This is your modern periodic table. This periodic table based upon the modern periodic law. According to modern periodic law, the physical and chemical property of the element are periodic function of their atomic number. This implies that the elements are arranged in the periodic table in the increasing order of their atomic number. Look at the periodic table. The atomic number of hydrogen 1, atomic number of helium 2, atomic number of lithium 3, atomic number of beryllium 4, atomic number of boron 5, atomic number of carbon 6, atomic number of nitrogen 7. Like that you think also atomic number of another element. From the data it is clear that the elements are arranged according to the increasing order of their atomic number. In this periodic table there are 7 horizontal rows are present and 18 vertical columns are present. Since there are 7 horizontal rows are present, so there are 7th period, and these periods are numbered as first period, second period, third period, fourth period, fifth period, sixth period and 7th period. Since there are 18 columns and the 18 columns are numbered as group, that means there are 18 groups. Group number 1, group number 2, like that you can also number all the group as 1, 2, 3, 4, 5, 6, 7, 8 up to 18th number group. Now I will discuss about the first period. Look at that. In the first period there are 2 elements are present. One is your hydrogen, another is your helium. That means the first period contain only 2 elements, that is hydrogen and helium. This period corresponding to the first energy level, that is K cell, or we can think the principal quantum number, that is your n is equal to 1. This period involves the filling of electron in 1s. Now take an example. Electronic configuration of hydrogen is equal to 1s1. Similarly, we think about the electronic configuration of helium. The electronic configuration of helium equal to 1s2. This period contains 2 elements. So, it is the shortest period among all the period because another period contains more than 2 elements. Now I will discuss about the second period. The second period contain element lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This period corresponds to second energy level, that is L cell, and it having principal quantum number n is equal to 2. This period involves the filling of electron in 2s and 2p orbital. Now take example. Electronic configuration of lithium is 1s2 2s1. Similarly, the electron configuration of beryllium is 1s2 2s2. You can also think about the electronic configuration of another element present in the second period. From the electronic configuration of all the elements present in the second period, it is clear that this period involves the filling of electron in 2s and 2p orbital. Now I will discuss about the third period. Look at the third period. The element present in the third period are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. There are 8 elements present in the periodic table. So we can write this period contain 8 elements from sodium to argon. This period corresponds to the third energy level, that is M cell. For M cell, the principal quantum number n is equal to 3. This period involves the filling of electron in 3s and 3p orbitals. This point clearly explained by the help of electronic configuration of the element present in the third period. Now I will discuss about the electronic configuration of sodium. The electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. Similarly, the electronic configuration of magnesium 1s2, 2s2, 2p6, 3s2. Similarly, we think about the electronic configuration of aluminum 1s2, 2s2, 2p6, 3s2, 3p1. From the electronic configuration, it is clear that this period involves the filling of electron in 3s and 3p orbital. Now, I will discuss about the fourth period. Look at that. In the fourth period, the elements present are potassium, calcium, scandium, titanium, vanadium, chromium, manganese, ferrium, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton. That means this period contain 18 elements from potassium to krypton. This period corresponds to the fourth energy level, that is n cell. For n cell, the principal quantum number equal to 4. This period involves filling of electron in 4s, 3d and 4p orbital. This point clearly explained by the electronic configuration of element present in this period. Now take the electronic configuration of potassium. The electronic configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Similarly, the electronic configuration of calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. From the electronic configuration, it is clear that this period involves filling of electron in 4s, 3d and 4p orbital. Now I will explain about the fifth period. Look at that. In the fifth period, the elements present are rubidium, strontium, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, indium, tin, antimony, tellurium, iodine, xenon. That means this period contains 18 elements from rubidium to xenon. This period corresponds to the fifth energy level, that is O cell. For O cell, n is equal to 5. This period involves the filling of electron in 5s, 4d and 5p orbital. It can be clearly explained by the help of electronic configuration of the element present in the period. Take an example. Electronic configuration of rubidium having atomic number 37 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. From this electronic configuration, it is clear that this period involves the filling of electron 5s, 4d, 5p orbital. Now I will discuss about the sixth period. Look at that. In this period, The elements are cesium, barium, lanthanium, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium up to lutetium. Then this period starts from hafnium, tantalum, tungsten, rhenium up to radon. This period contained totally 32 elements, and this period is considered the longest period. This period corresponds to the sixth energy level, that is p cell. For p cell, the principal quantum number equal to 6. This period involves the filling of electron in 6s, 4f, 5d, 6p orbital. Now I will discuss about the seventh period. This period starts from Fr, that is your francium, to Og. The elements present in these periods are radioactive. From francium to uranium, the elements are natural occurring and remaining elements are artificially prepared. This period involves the filling of electron in 7s, 5f, 6d and 7p orbital. Below 7 periods, another 2 small periods are present. The elements in the first row are called lanthanide and those in the second row are called actinide. The lanthanides and actinides are called inner transition element. Now I will discuss about the group. The vertical column in the periodic table are known as group. According to old recommendation of IPAC means International Union of Pure and Applied Chemistry. The groups are named as IA, AA, IIIB, IVB, VB, VIB, VIIB, VIII, IB, IIB, IIIA, IVA, VA, VIA, VIIA, VIIIA. From the naming, it is clear that each column of the periodic table is represented as group, but VIII group is made by 3 columns. So, there are 16 groups made by 18 columns in this periodic table. But according to new recommendation of IPAC, the group in the periodic table are numbered as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. That means each column is represented as a group. As a result, the 8th, 9th, 10th group combinedly considered as VIII. The first group, that is IA group, contain 6 alkali metal from lithium to francium and 1 non-metal, that is your hydrogen. The second group, that is AA group, contains 6 alkaline earth metal from beryllium to radium. The group IIIB, that is your third group, IVB fourth group, VB, that is your fifth group, VIB, that is your sixth group, VIIB, that is your seventh group, VIIIB, that is your 8, 9, 10 combinedly called, that is your VIIIB, and another group, that is your IIB, that is called 11th group, and IIIB, that is called 12th group, contain 38 transition metal element. The group 11, that is IB group element, are called coinage metal. The group 15, that is VA group elements, are called picogen. The group 16, that is VIA group elements, are called chalcogen. The group 17, that is VIIA group element, are called halogen. The group 18, that is VIIIA group elements, are called aerogen or noble gas or inert gas or rare gas or zero group element. That is all about group and period of modern periodic table.